Hello class, we're about to start section 7.2, graphing quadratic functions in standard form. Now standard form of a quadratic function is f of x is equal to ax squared plus bx plus c. Now we have our vertex, negative b over 2a, that is our x value. And then the f of negative b over 2a, we know that that is our y value. Now it says here, if a is greater than 0, we know that that means that a is positive because any number greater than 0 is positive. The parabola opens and is upward. Now what I'm going to do is this here. As you all saw that the letters were jumping here. So what I'm going to do on this side would be for the first blank, and on this side would be for the second blank. So it would be upward. Oh, and it's moving here. The parabola opens upward, and the vertex is the blank point, it's the minimum point. Okay, now we go down to the second one. If a is less than 0, that means that a is negative. The parabola opens, and that would be downward. Now, and the vertex is the blank point. I'll put this here to be maximum. Okay, so now let's go through this again. If a is greater than 0, the parabola opens upward, and the vertex is the minimum point. If a is less than 0, the parabola opens downward, and the vertex is the maximum point. Now we scroll down here to example 1. It says let f of x equals x squared minus 6, a negative x squared minus 6x minus 4. A is equal to negative 1, b is negative 6, and c is negative 4. Because remember, in the standard equation here, we have y is equal to, it'll be ax squared plus bx plus c. And all we did here was take out the values of a, b, and c. Now it says find the vertex by hand. So we have x is equal to negative b divided by 2a. Now we know that b is negative 6, and we know a is negative 1. The opposite of negative 6 we know is positive 6, and 2 times negative 1 is negative 2. So our answer here would be negative 3. So our vertex is negative 3. And now we're going to plug this in order to find y. So we have f of negative 3 is equal to, but we know that's really y equals, and we know f of negative 3 and y are the same thing. It's the opposite of negative 3 squared minus 6 times negative 3 minus 4. So we had an opposite, negative 3 in parentheses squared is 9. A minus 6 times a negative 3 is negative 18 minus 4. Minus 9 minus 18 is a negative 27 minus 4, which will give us negative 31. Now, that is our vertex. Now we scroll down. Well, before we do C, we need to write this as an ordered pair. We know that our x value is negative 3, which is our vertex, and our y value here should be, actually this is supposed to be a positive 18. So this was actually a little bit of an error. I guess it might have disappeared. So I need to change this. So we had negative 9 plus 18, which is positive 9, minus 4, which is 5. So this answer should be 5. So we will have negative 3 for x and positive 5 for y. And that is the final answer for the for this point here. Now, we go down here. It says, is the vertex a maximum or minimum point? Now, we have negative 3, 5, so we would draw this here. We'll draw a quick little sketch. Now, if you look here, remember, we said earlier in the directions, if A is negative, that means that the graph opens downward. and that this right here is a maximum point. So our final answer is, this is maximum, and it's because the parabola faces downward or opens downward. And just a little side note, because A is equal to -1, which means that A is less than 0. So that automatically means it's a maximum point. Now, we have the TI-84 calculator instructions, which you can read at your leisure, and it will show you how to put this in a calculator and how to find a vertex. And here is the website here. Now, we scroll down here to our next page. We have example 2. Now it says here, find the vertex by hand. It says, note, you can verify with your calculator. So, we know here that A is a -1/2, B is 4, and C is -10. Now, what we would do is we would have X is equal to -B over 2A. And we know B here is 4, so it'd be the opposite of 4, all over 2 times -1/2. So we have -4. 2 times the -1/2 we know is -1. So our final answer here is 4 for X. Now to find Y. We have Y is equal to f of 4. And we have -1/2 times 4 squared plus 4 times 4 minus 10. So this will end up giving us, after we put this in a calculator, this will give us -2. So our ordered pair would be 4, -2. Now again, since A is less than 0, we already know that it's a maximum point. And it's because the parabola opens downward. Now, we look here at C. It says for C, place the vertex in the middle of the table and then find a couple of points on either side of the vertex and place them in the table, then graph by hand. Okay, now we come here. Hopefully this will not jump. We would do this here. The point we have is 4, 2, or 4, -2. So in the middle here, this would be 4, -2. Now we can find these values in our calculator, which you can find by inputting this in your Y1 and looking at a table. So we could have 0, -10. We could have 2, -4. We could have 6, -4. And we could have 8, -10. Now, what we would need to do here is we need to plot these points. Okay, we have 0, -10, which we know would be about here. We have 2, -4, which would be here. We have 4, -2, which would be here. We have 6, -4, which would be here. And we have 8, -10, which is here. Now we can connect these points. Now, of course, this is supposed to be more of a curved shape. We can draw our arrowheads to let it be known that it goes on forever. Now it says here, state the domain of f of x. Now if you look here, we will more than likely go, we go past the y-axis. So x, there are no restrictions on x. So our domain is -infinity to infinity, because we could use any x value. Now it says state the range of f of x. Now if you notice here, this is our maximum point, which is -2, where y is -2. So it would never go above -2. But if you notice, it would do all values below -2. So we would have negative infinity, and we will also have -2, and that will be included. So our values are from negative infinity to -2 inclusive. Now we scroll down here to example 3. Now example 3 says, let f of t be the number of wildfires in the U.S. in thousands of dollars at t years since 2000. So we know the year 2000 is actually our 0. Now, this should be, instead of thousands of dollars, this should be in thousands of fires. Okay, now, if we look at this graph here, we come down here to this question. It says, consider a scattergram of the data. Is it better to use a linear, exponential, or quadratic function to model these data? Explain. Now, if you notice here, this is more of a curve shape. It's more like a parabola, even though it goes off to the side here. But if you were to connect this, it looks more like a parabola, not including this point here. Okay, so our answer here would be quadratic, because the graph makes a U shape. And it goes down because it goes down and comes back up. Okay, now we go here to B. It says here, verify the quadratic model. F of t is equal to 2.14 t squared minus 15.03 t plus 93.58 fits these data well. Include a sketch of the graph. Now, does the calculated graph appear like the Excel one above? Explain. Now, we're going to use the calculator to draw a scattergram. Now, I took the liberty of adding in this information. Okay, now we know we're going to use the calculator to draw a scattergram with the model. So we use the calculator. It looks approximately like this here. And it looks nothing like the Excel because of the scale. So basically, that is your answer. Now, we scroll down here. It says, find the vertex of the model by hand. Now, we would do x is equal to -b all over 2a. So we add an opposite of -15.03 all over 2 times 2.14. That'll give us 15.03 over 4.28, which is 3.511. So now we have y is equal to 2.14 times 3.511 squared minus 15.03 times 3.511 plus 93.58. And this would give us approximately 67.4. So what we will have here, our ordered pair would be 3.511, comma 67.4. Now I took the liberty of writing this out. Since our A is positive, that means that our graph opens upward and we have a minimum point. Our vertex this is the minimum point. So the number of wildfires in the U.S. was at its lowest level in 2003 at only 67.4 thousand wildfires. Okay, class, for this last problem, it says verify your result by using a calculator. So you will input all this information in the calculator, and I drew the sketch here. And then you will click in your calculator, you will hit second, calculate, and 3 for the minimum point. And then it will give you 3.511, 67.190. I know it's slightly different than what we did by hand, but it's approximately the same. And this is your final answer.